So the definition of union is a collection of heterogeneous or dissimilar data elements. Union is a user defined data type. So the syntax is union followed by the tag name. We can write the member list elements, and next after closing we need to put a semicolon. So the difference between structure and union is the size of structure variable will be the sum of sizes of all the individual member elements, but the size of union variable will be the size of highest data type size of the member elements. So as it takes common storage for storing member elements, because of which writing and reading of data in the member elements should be done at a time. Example of union. Union student, char name of 25, int age, char branch of 10, float percentage, closing it with a curly brace followed by semicolon. Now here union of S1, S2, S3. So here the size of S1 will be 25 bytes because the highest data type size is for name, that is 25 bytes, which is of character type. So here the size of the union will take the highest data type size.
Let us see one example program. Now the next program is to understand the memory allocated to the union. The memory allocated to union. So very simple. Here the syntax for union is union followed by the tag name. So here I will be using union. Now if we can closely look into this program for union takes the highest data type size to allocate all the individual member elements. Union takes highest data type which has been allocated as part of this member list. Now if I run this code and see for the memory, so you can see the memory allocated. Here we need to change it as union. Here we need to change the union. So this is like union student name. So let me execute this code and check the size allocated for the individual variables. Now let us see the output of this. As I said, union takes the highest data type size for memory allocation. Now individually they are allocated with 17, 4 and 4 followed by 8. But the thing is, if you can see here 24, it has been allocated with the multiples of 4. As I said, memory will be allocated as part of the advanced compilers for data alignments as part of the given member elements. So here actual size is 17, but because of the alignments it is going to take the multiples of 4. So that is the reason it is taking the extra bits 24. So the size of union takes the highest data type size as part of the given member list element. So this is how the memory associated with the union we are going to get it. Now let us take the next program to understand the memory locations. To understand the memory locations of structure. Memory locations of structure. To understand the memory locations of structure member list. Of structure member list. Now here I'm going to take it as struct. So this is struct followed by student. This is struct. Now earlier we have seen the sizes of each and every identifier. Now let me show their memory location. So let me just change this. Printf the memory location, or I can say or address. The memory location or address of name. So where this name is being stored. So in order to access the address we can use %u. %u. Here in order to take the address within the printf we need to write address of s1 dot name. Address of s1 dot name. So similarly, if I want to access the memory locations of all the identifiers whatever I have specified within the structure, so this is how we are going to access the address location. The memory location or address of what is the next identifier? Mark. So s1 dot mark. S1 dot marks. Next, the memory location or address of percentage. So if I want to give in a new line /n, so So this is also a slash n. So this is how we are going to take the new line. So percentage is s1 dot percentage, s1 dot percentage, and the next one is fees. So the address location of fees, s1 dot fees, and the next one is the memory or address location of s1. So let us see their address location. Let me execute the code and understand the memory locations or the address of the structure member list. So if you can see here the memory addresses, the memory location of or address of name. So name address is this one. Let me just take the last two digits, 60. Okay, 60. Now 60 adding with 17. 60 adding with 17. The next memory location you are going to get it. So as we know that extra padding bits are also taken. So 60 plus the extra padding bits are included. It is going to take 80. The next memory location is 80. 80 followed by, from here you can see here, 80 followed by the next one is percentage, which means integer take 4 bytes. So the 4 bytes will be 80. After the next location will be 84. Next double is 8 bytes. Double is 8 bytes. So if you take 8 bytes or after this 84, 84 plus 8, that is 92. 84 plus 8 is 92. And here the entire structure variables, like as we have seen for arrays, there is a base address. The first element's address location will be the base address. So if you can see the address of S1 and the address of first identifier what we have used as part of the structure, their addresses will be the same, which means the memory location is pointing to the first identifier of the member list within the structure. So this is how we are going to access the memory. So you run this program for number of times, the memory will be allocated for every compile time. The memory will be allocated for every compile time. Now we have compiled like this. Next, if I am executing once again, you can see the numbers will be changed, which means for every run compile time, the memory is allocated, and depending upon the availability of the space, the elements are being allocated with the different location, right? So if you can see here, now the address locations are being changed, all right? So now you can see 72 and adding this 17 plus is 20, 92, next 4, 92 plus 4 is 96, 96 plus 8 is, again we need to add last 3 digits. Let me take 696, 696 plus 8 is 704. Okay, the first element is as it is name, so you can see the first element address and the S1 identifier address. So this is how you are going to get the memory locations of structure variable. Now let us understand the next program to understand the memory locations of union member list. So here the syntax is union followed by the tag name. So union student, as we all know, union takes the highest data type size to store all the member elements. Now whenever I am using union, if you see the memory address location, so let me execute this code and show you the memory location. So in the structure we have seen the memory locations were different, but if you can see in the union, it takes the highest data type size, and that particular memory location itself, the entire data is getting stored. So for memory constraints where memory should not be wasted, and that scenario we are going to use union. But there is also a disadvantage that in union we should read the data and print the data simultaneously. Overwriting of data is not possible, right? Now you can see here the memory location of address of name. So if you can see the address of name, address of marks, address of percentage, address of fees, and address of S1. So all these addresses are same, which means union holds the memory address of the highest data type within the given member list, and it takes that particular storage location for allocating the values of the different member list associated with union. So this is the actual difference between the structure memory locations and union memory locations. You run the program again for the next time, it will be allocated with a different address, and the address will be unique for all the member list elements. So as I said, at runtime the memory locations will be allocated. So you can see here earlier the program, just you can remember 960, okay, 231572690. If you want, you can just note down this address. I am compiling once again, so I'll make you understand that the memory locations associated with the individual member list elements will be allocated at runtime. Now you can see here the different address location, but it is common for all the member list elements. This is the very important point which you need to remember. So once again, I'll give you a glimpse. Structure variables store in their respective memory locations according to their size, and the total of the structure individual data type sizes will be the size of a structure identifier. And as part of union is concerned, union takes the highest data type size, and the memory locations will be the unique memory location for all the member list elements. And the disadvantage of union is we need to read and the write data at one time. You cannot read multiple data altogether because the memory location is a common memory location. If you see this example, to declare and initialize union variables at runtime. So here we are going to read this data members at runtime, but if you can watch this output, like you can see here, I'm reading the name, I'm reading name at runtime. So let me read the name as rock, let me read the name as rock, percentage, marks, first one is marks, next percentage, next what is the fees. So I have read this fees. Now if you can see here, you're not going to get any of these values like name, marks, percentage. Name will be null, marks is 0, and percentage is 0.00. So with this we can conclude that, so in a given union, the member list elements should be read and printed immediately. So you cannot use multiple reads and you cannot print at the different output as we have seen for the structure. Now fees was read in the last, so that there is no change after this fees. That is the reason we are getting this fees value. Now let me execute the code by taking the printf and scanf and immediately printing the value of the given union variable. Now you can see here, printf enter the name of the student. So I am reading the name. So as soon as I read the name, I need to print it. As soon as I read the name, I need to print it. So just I am replacing here. As soon as I read the name, I have printed. So this is 1. So please try to understand this. As soon as I am reading the name, I am printing the name. That's it. Next, here no multiple reads will be done. That is, enter, first one is marks. Enter marks of student. So first we need to take marks. The rest of the things we need to read again in the later. Okay, that is marks. And as soon as we read the marks, we need to print the marks. So in order to print the marks, this is the printing of marks. Now similarly, here we need to printf enter percentage. Enter percentage. Now immediately after reading percentage, we need to print it. Scanf percentile f address of what is the percentage, s1 dot percentage, s1 dot percentage. Now immediately I am going to print this percentage. Next, I am requesting the user to enter the fees. After percentage we have fees. Now percentile lf s1 dot fees, s1 dot fees. Next, immediately after reading fees, I am printing it. So in union, there is no multiple reading of data. So once we read it, immediately we need to print in the union. Only then we can get the output. What is the reason? The reason is the memory location is the same memory location for storing all the individual member list elements. Now let me execute this code and show you the output. So I am taking the name as Hema. Okay, now you can see here immediately the name has printed Hema. Next, enter marks of student. So let me enter the marks of student as 99. And what is the percentage? Immediately the marks are being displayed. Next, enter the percentage. I am entering the percentage as 95. Next, immediately as soon as I entered the percentage, I got the percentage. Next, enter fees. So let me give the fees as 5000. So fee is equal to 5000. So this is how we need to read and print immediately for union.